Elon Musk just said something most people missed. He believes the world will need 3 to 5 Optimus robots in industry for every personal one in a home, and that the total fleet could reach tens of billions of units. Listen to that sentence again. Tens of billions. That is not a typo. That is a CEO publicly betting the future of his company on a humanoid robot most people still think of as a stage prop. So, what is actually inside Optimus Gen 3 that has Tesla convinced it can replace human housekeepers? Why is the launch taking so long, and what does Musk know that the rest of the industry seems to be missing? Here is what almost every video about humanoid robots gets wrong. They focus on whether the robot can walk. Walking was solved years ago. The robotics industry is full of machines that can dance, run, perform impressive stunts, and rack up millions of views online. After the headlines fade, almost none of them end up doing anything useful. They do not live in your home, they do not work in your kitchen, they cannot replace a real housekeeper. Tesla is no longer trying to prove Optimus can walk. The company is trying to prove Optimus can work. That is a far harder problem to solve. According to Musk, Optimus Gen 3 will be the first version designed around actual, real-world labor. The robot needs to understand its surroundings, recognize objects, respond to people, control the force of its hands precisely, and reliably perform thousands of different tasks. Not one task in a controlled demonstration. Thousands of varied tasks, every day, without supervision. Here is the surprising part of Tesla's plan. The first deployment target is not the home, it is Tesla's own factories. That sounds counterintuitive until you understand why. Factories generate millions of repeatable tasks every single month. That repetition creates the training data Optimus needs before it ever steps into someone's house. Unlike robots that appear briefly in carefully staged demos, Optimus has to prove it can work for hours every day inside Tesla facilities. The robot is already being trained on repetitive material handling and logistics tasks that human workers perform thousands of times daily. This is the same playbook Tesla used for full self-driving. Put the technology into the world, let it make mistakes, collect the data, update the software. Repeat the cycle until the system reaches human-level accuracy. The robots go to work, the robots make mistakes, then Tesla collects the data so the next iteration improves. That feedback loop is the whole strategy. Most coverage of Optimus Gen 3 focuses on the redesigned look or the new 22 degree of freedom hands. The technology that will actually decide whether this project succeeds is hidden inside the robot's chest. It is called AI-5, and Musk personally spent months helping develop it. According to Musk, AI-5 delivers AI processing performance comparable to extremely powerful GPUs that cost tens of thousands of dollars while drawing only about 250 watts of power. That means Optimus can process data directly inside its own body without needing an internet connection or cloud computing. Every decision happens locally, every reaction occurs in real time. Cloud latency would be unacceptable for physical tasks where a robot needs to respond to a slipping object or a moving person instantly. AI-5 eliminates that delay entirely. This is what Tesla believes will allow Optimus Gen 3 to graduate from flashy demonstrations into actually useful work. No matter how powerful the AI is, none of it matters if the robot cannot physically interact with the world. In humanoid robotics, legs let a robot move, but hands decide if a robot is actually useful. A robot can walk perfectly and maintain flawless balance, but if it cannot handle objects with precision, it remains a demonstration machine, nothing more. Think about ordinary daily tasks: folding laundry, washing dishes, picking up children's toys, feeding a dog, watering plants, organizing groceries in a refrigerator. These actions feel effortless to humans. They are incredibly difficult for robots. The original 2021 Optimus prototype had hands that resembled industrial grippers. Gen 2 advanced to roughly 11 degrees of freedom and could perform basic manipulation. Gen 3 nearly doubles that range of movement. The hands themselves are only half the story. The actuator system behind them is where Tesla is doing something unusual. Most robotics companies buy actuators off the shelf. Tesla is developing custom actuators for different parts of the body. The hip joints require one type of actuator, the shoulders need another. The wrists require something different. The fingers need an entirely separate class of actuator. A single actuator design cannot serve the whole robot, so Tesla is engineering each one specifically for its role. Musk has repeatedly emphasized that the hardest problem facing Optimus is not artificial intelligence, it is manufacturing. Anyone can build a robot for a carefully controlled demonstration. Very few companies can build 1 million robots per year. That is where Tesla becomes truly dangerous. People often compare Optimus to Boston Dynamics' Atlas. That comparison is understandable. Atlas is one of the most impressive humanoid robots in existence. It performs movements that leave audiences stunned. It carries heavier loads than Optimus. It features some of the most advanced mechanical engineering ever placed inside a humanoid. But Tesla is playing a different game entirely. The goal is not the most spectacular robot ever built. The goal is the first humanoid robot that can be manufactured at massive scale. A robot that costs hundreds of thousands of dollars and takes months to assemble can be an incredible engineering achievement. It will not change the world. Tesla wants a robot produced in enormous quantities, continuously improved through software updates, and eventually deployed everywhere from factories to private homes. Here is the part Musk gets excited about that gets buried in most coverage. Every Optimus in the future is not just a worker. It is also a mobile sensor constantly feeding data back to Tesla's AI system. One Optimus might discover a faster way to carry food in a restaurant. Another might find a better method for organizing warehouse inventory. A third could learn to clean a house more efficiently or operate a vacuum better. All of that learning gets shared across the entire fleet. Translation: if you buy 2 Optimus robots and train one to cook, you do not start from scratch with the second. They share what they have learned. Every new robot in the world makes every other robot smarter. That feedback loop is something very few companies on Earth are capable of building. The latest Gen 3 design also addresses something that quietly matters more than people realize: water resistance. Recent images suggest Optimus fingers now have a much more sealed design than earlier generations. The body is largely covered by polymer shells and composite materials instead of exposed mechanical parts. Nobody wants to spend tens of thousands of dollars on a robot and worry every time it rains or every time the robot needs to wash a dish. Tesla is also working on natural language communication through Grok voice integration. The goal is a robot that understands human speech the way humans communicate with each other, not a machine that responds to rigid commands. Even if Optimus cannot handle every complex task immediately, a robot that understands you naturally would already be far more appealing than anything currently available. Put it all together. AI 5. 20. 2 degree of freedom hands. Improved water resistance. Advanced sensors. Natural language understanding. Optimus Gen 3 has genuine potential to become a real household assistant. Tesla is not delaying because the robot does not work. They are delaying because they want the public launch to be a useful product, not an impressive demo. The biggest question remains: even if Tesla solves every technical challenge, can they actually manufacture Optimus at a scale large enough and at a price low enough for millions of households to own one? That may end up being the toughest test Gen 3 ever faces.